Hi everyone, hope you're all okay. So I'm bringing this recording from all the way from sunny St Helens. We'll just see how it goes, give it a try, and at the end of the week I'll ask you how you think it went, if it's easier me doing it this way. There will be points in this recording I will need you to pause it a lot to write things down. That's because the app that I'm doing it on will only let me record for 15 minutes at a time. So I want it all in one clip really. So I'll tell you to pause, to write things down, write it in your booklet or type it however you're doing it on paper, it doesn't matter. But there'll always also be little videos, little experiments. So I'm going to send you the PowerPoint slides separately so you can click on the links for things and always have it there without me talking in my Northern St Helens accent over it. And just do what you will with it, pause it whenever, see whether it works for you. If not, you've always got the other copy of it anyway. So let's get started. New topic, last one of the year really before we start to consolidate a lot. So memory is generally a topic that the students tend to forget. They tend to find it the most difficult, and we don't know whether that's because of the content or it's because we always do it last thing in the year. It might be that students are tired, we don't know. But there's a lot of things to it. We're going to give it a go. We will be recapping things as well, so just do as best as we can. This is still a strange situation for all of us. It's very strange not being able to see the people I'm talking to as I'm trying to teach a lesson. So do bear with me on the technology front as well. So here's just a few questions to think about really to get you started on the memory topic. So what is your earliest memory? Is there a reason you think you remember this? So mine personally, I remember my brother being born, probably because it was the most traumatic time in my life. But that's a significant event in my life. So that's why I remember it. I was 3.5. I don't remember anything before it. Does it necessarily mean that I didn't make any memories before this? Some people might only remember something from when they were 4 or 5. Does that mean they don't store any information before this? So have a think about those questions. There is a link to a YouTube video that's a nice introduction, few experiments and games on there that you see as well. So have a watch of the video, think about these questions before we get into it properly. So hopefully you've had a think about those questions, you've watched the videos to give you a nice introduction, and now you will need to know what we're going to be learning this week. So for this week we're going to be learning about the coding capacity and duration of the short-term memory and long-term memory. You might already know more about memory, but for now that's all we're focusing on, and then we will build on that as we go. Now you need to know research into the coding capacity and duration of both the short-term memory and the long-term memory. There's quite a lot to them. They're not key studies in that they won't say how many participants are there in the Peterson and Peterson study, but there might be a general question of what is the duration of short-term memory, and you will be expected to put the full study down. So it is important that we do know the studies. It's not just important for this topic or this few pages, it also helps us build upon the models of memory, which we will do in the next few weeks. And models of memory are just different psychologists proposing different ideas about how our memory works. These all are included, so we need to make sure we know them, revise them, make any cue cards, anything like that, because this is the bit, or the starting bit, that students tend to forget quite a lot. I'm going to do some experiments as we go as well, like I would in class. You'll need your phone as a timer, you'll need a piece of paper to write on, try and follow the instructions as best you can. I know it's quite difficult for you to try and look away from a list of words when they're on your screen quite clearly, but it's just a little bit of fun really, trying to make life a little bit more interesting, or as much as I can. So we are going to do coding first, but we are going to have a little experiment before I start the full research. So need a piece of paper, timer, let's see how we get on. So your instructions for experiment number 1. I want you to do it one list at a time. It's the exact same procedure for each. So I'm going to put list 1 on first, give you time to do that. So pause it whilst you're doing it. Then I'll give you list 2. So first of all, I want you to time 30 seconds reading the list. See how many times you can go over it in your head or whatever you can in 30 seconds. Then I want you to cover the words over or look away as best you can. Count to 5 in your head and then write them all down. You've got 30 seconds to do that. You don't have to do it in order, just the words. Then check how many you got right. Then I want you to do the exact same with list number 2. So list number 1, first of all, if it would appear, that would be great. There we go. List number 1, pause it here, give yourself a go at list number 1. So hopefully list number 1 is done. Here's list number 2. Exact same procedure. So hopefully you've got 2 scores. Have a bit of a comparison. Did you do better on list 1 or did you do better on list 2? Why have we got to do this? These are coded differently, and I'll go through what they mean in a second. So just have your 2 scores next to each other. So in theory, now I've put that in italics, theoretically, because I know what our experiments are like in class, you should have scored higher on list number 2 than list number 1. Not shockingly, you probably will have scored the opposite way around because that's how it usually goes with us, but they should have been harder in list 1 because they are acoustically similar. They all sound the same. And that causes your brain to mix them up, blend the words together, and possibly even make up words that sound the same or rhyme with them, even though they weren't on the list. The ones on list 2 were acoustically dissimilar, they sounded very different, so they should have been easier to recall. So this is a very similar experiment to the one by Badley, and that's the coding of memory. Page 3 of the booklet, if you're typing into it or if you're writing into it, if you're doing it on paper, just put page 3 in the corner. We'll sort that out when we get back to college. So, you need to start with the coding. So coding you need to know the definition of. This is already typed into your booklet, but you need to make sure that you know it. So it's the format in which memories are stored. Now, a lot of the research in memory is done by Badley, who is here, but this study, 1966. For some reason, students find this study extremely difficult to remember because there's a few different ways to it. They find it quite confusing. So I've tried to break it down as much as I can into short-term memory and into long-term memory, but I don't want you to write anything until the summary slide. So I've put a screenshot of the textbook. It's not that clear, I won't lie. A bit fuzzy because I'm not that great of a photographer, but I've done the best I can. So don't write anything down until we get to that slide. It's important that you know though that these aren't separate studies. This was all done at once. There were 4 separate groups of people, so it was an independent groups design. Make sure you know what that means because that matters. So even though I've presented it as 2 slides, it is still one study. So the short-term bit. Participants were given one of 2 lists to remember. So one group had list 1, a different group had list 2. They were either acoustically similar, like list 1 of our experiment that we've just done, or acoustically dissimilar, like list 2. Participants then had to recall them immediately, so there was no task to do, it was just here's some words to remember, now recall them. And they found that participants had serious problems remembering and recalling the acoustically similar words immediately after learning them. So they concluded that short-term memory is acoustically coded, so it's coded in the way that we hear things. Now, long-term memory, similar procedure. Again, they were given one of 2 lists, call them list 3 and list 4. So one group given list 3, one group given list 4. And they were either semantically similar, so they mean the same thing, like big, huge, massive, or they were semantically dissimilar, so they had different meanings, like giraffe, pepper, and rain. Participants then had to complete a 20-minute task that was completely separate to these words, and then recall the words after that. What they found was that participants had problems remembering and recalling the semantically similar words 20 minutes after learning them. So these caused confusion, caused them to be blended together in the same way as the acoustic ones did for short term, so they concluded that long-term memory is semantically coded. That's the study. Like I said, I'll give you the summary. Like I said, it's not very clear. Try your online textbook. This is a slightly different textbook that just breaks it down in a nicer way for me. But pause it here, write everything down, rewind if you need to. So hopefully that all makes a little bit of sense. We still need to evaluate it. Now I don't want you to write full PCs at the minute, but just be aware that you could write these as PCs and your E would essentially be whatever from Badley that you are using. So here's some quick ideas. I'll go through them very quickly, pause it to write a few ideas down. I only do it briefly, it's at the bottom of page 3. So there are independent groups doing different people doing each list. What issues might we have there? If I split you into 4 groups in class, what issues might we have between the different groups? It's a lab experiment, so there are positives and there are negatives of that. Make sure that you do put the positives in there. This is a task that isn't really done consistently in your life. I might ask you to recall key terms, but I don't really ask you to recall random words. So what is that called? And long-term memory can also be coded visually, but it doesn't take that into consideration. It says it's just semantic. So what issues might we have there? So pause the video, write some ideas down. Don't be too detailed, but make sure you have a good overview in there. So that is coding done. We're going to try and get through capacity as well today. So a few more studies, a few things for you to have a go at. So capacity. The definition is the amount of information that is able to be held in a store. Now you've got a box for long-term memory, box for short-term memory. I'm going to start with long-term memory even though it's the second one down. Can I actually test your long-term memory? If I get you to sit down and I say, write every single memory from the past 10 years, how long would that take you, first of all? And how do I know if you've got that wrong? How do I know that that's everything? So, can I physically do it? The answer really is no. There's no real way of doing this. I don't know what's right. I don't know what's wrong. I don't know whether that's everything. So, it's generally accepted that the capacity of long term memory is unlimited. There's no research. So in the box where it says long-term memory capacity research, there is none. It's just that it's generally accepted that it's unlimited. How can you evaluate based upon that? There's no actual research, so how can we prove it right or wrong? But it does have good explanatory power because it makes sense. So now onto short-term memory. Here's a little experiment for you to have a go at. You might have done it before, you might not have, but you will need to pause it. Have a read through the instructions, essentially memorise a line at a time, cover it, see if you can recall it in order. Have a pause of it, see which line you can get to. So compare your results in that experiment that you've just done with the study and the results from Jacobs 1887. No, that's not a misprint, it is an extremely old study. Again, I'm sorry this isn't very clear. I will try and find a better way than me taking photos of stuff for you. But essentially that was the very similar method to Jacobs. Participants were presented with a string of letters or digits. They had to repeat them back in order. The results were that the majority of the time participants recalled between 9 digits and 7 letters each, and this capacity increased with age during childhood. So the capacity of the short-term memory is 5 to 9 items, but we can chunk them, and chunking was looked at by Miller. If it had changed slide, there we go. So Miller 1956 looks at chunking. Most things come in sevens or within the short-term capacity, so 5 to 9, 7 plus or minus 2. But we can remember home phone numbers, mobile numbers, which are a lot bigger. So we tend to chunk things into threes. So in a phone number, you'll say 3 digits at a time, and your brain processes them as one thing, and that's how we can remember longer digits. So pause, have a write down of this in there as well for me. And now we need to do a bit more evaluation. So think about the experiments, think about the settings that they're in. If you think about Miller though, we do tend to chunk things quite a lot. So that might have a better mundane realism than say the lab experiment of Jacobs would. So think about the type of experiment, how old they are, what's the key term for that. It's a type of validity as a bit of a hint. But just a few generic bullet points will be absolutely fine in those boxes. And now's a good time to take a break. I think we've done quite a bit there with a few experiments, pausing it and so on. So that's lesson 1 of the week done. Good time to take a break. See you in a few days to do lesson number 2.